Hello, this is Dhatri from DIY project group 15 of section 15, and our DIY project is a smart solar segregator. It will be helpful if waste segregation can be achieved by automation in a sustainable manner. That is our idea. So we have included waste management in the form of segregation of wet and dry waste, and we plan to do this in situ. And we will use automation because that gives us maximum productivity and efficiency. Also, whatever technology we make should be sustainable as well, and harnessing solar energy is a crucial development for this. So we are going to include that as well. We have used components like Arduino, servo motor, touch sensor, moisture sensor, a solar panel, and other miscellaneous items such as a breadboard, jumper wires, and cardboard. So let's take a look at the code now. Here's the code for our smart segregator on Arduino Uno IDE. We have to include servo H because we have a servo motor, and here we've initialized the variable servo. The servo motor is attached at pin 9 of the Arduino. The moisture sensor, which takes an analog input, is attached at A1, and the touch sensor, which takes a digital input, is attached at pin 2. In our void loop, we are reading the moisture input and touch input. And if the moisture input is greater than a certain value and the touch input is true, it is a dry material, which basically means because dryness is directly proportional to voltage. And this signifies that the moisture input by the moisture sensor, that will be inversely proportional to the actual moisture present in the material. We shall learn more about the loop code during the simulation.
Let's see the simulation part now. Here we have this virtual prototype of our actual working model. In reality, we only have 3 pins in our soil moisture sensor, but this extra pin is provided by Proteus so that we can gain control over the moisture sensor. And we have attached a potentiometer here. So as we just alter the resistance values, accordingly our voltage value changes, and this output terminal of the soil moisture sensor sends the same voltage value. And we have even attached a voltmeter here so that we can read that voltage value whichever is going across. So this voltage value reaches this analog pin of the Arduino, and the Arduino converts that analog voltage into a digital value. So that digital value is checked with our piece of code, and the Arduino handles the components accordingly. So the only thing I want to press over is like the digital value sent by Arduino. It varies between 0 to 1023, and it's directly proportional to the applied voltage. Like if the supply voltage here is 0, then the digital value which it will read will also be 0. And if it is maximum value of it, like 5 volts, which is in this case, so then it will be 1023. So let's look. So in the simulation part, let me turn it on. So here is our code, and what we can see is that when the neutral condition is there, our servo motor remains in the 90-degree state. In the neutral condition, when there is nothing at the touch sensor, it's at a 90-degree angle. And once both the touch sensor receives a positive and our digital value goes beyond 200, our motor rotates in clockwise fashion. So let me turn it on. So here is something, and the digital value will also be more than 200 for 2.5 volts. And here we can see it has rotated by 180 degree as it was written in the code here. And once the digital value is less than 200, our servo motor will rotate in anti-clockwise fashion and until it reaches the 0 angle value. So you can see if I decrease the resistance value to an extent that the voltage goes below 1, so our servo motor starts rotating in anti-clockwise fashion until it reaches 0. So that's how we can segregate whatever material we put over the touch sensor.
To harness the solar energy, we require a voltage regulator, which we have shown here on Proteus. But however, due to product unavailability, we couldn't include it in the working prototype. So this is our working prototype, and these are the pictures. And this is the solar panel, which we couldn't unfortunately include. And now we shall see the working model. This is our hardware prototype, where from the Arduino, the plus VCC wire is connected from the Arduino to the breadboard, that is a circuit board. Then the plus VCC wire goes to the touch sensor first, and then it's followed by the moisture sensor, and then also followed by the servo motor below. The pin analog pin A1 in the Arduino is connected to the moisture sensor. The pin 2 is connected to the touch sensor, and pin 9 is connected to the servo motor. And now we shall see a sample of dry waste. The angle changes when it detects dry waste to the right. Similarly for another dry waste material. Now the wet waste material goes to the other side, since the moisture sensor detects moisture in the wet waste. Our team was comprised of 4 members. Anamitra Mukhopadhyay did all the coding using the Arduino Uno IDE. Rishabh Yadav did the simulation on Proteus. Apoorv Modak was responsible for hardware assembly and making the working prototype. And I'm Dhatri Raghunathan, who did the logistics and presentation. Thank you.